You're welcome back to a session with your brother, edu-aider. Thank you for joining me again on another episode of differentiation, that is differential calculus. Now, quickly, we will be talking about basic rules in differentiation achieved by first principle. And after this, we look at some special derivations. These are the two things we'll be doing in this video. Quickly, now, if C is a constant, if you have a function such that in that function is a constant, either C, D, whatever, any alphabet, anything, it is noted or denoted by a constant. Now, a constant can be in the form of alphabet or a value, letter, like it could be C, it could be A, it could be 2, it could be 3, nothing. So, such that it is not carrying a variable. It's not divided nor multiplied by a variable. So, we say if C is a constant, then D, the x of C, is equal to 0. D, the x of C, will be equal to 0. Now, if A is a constant, then D, the x of A f of x, that is A times the derivative of a function. So if you have this, that means let's say here, let me do something here. We have here, if you have, for example, y to be equals to 2. 2 is a function, it is a what? This is a function of this, but this is a constant, it's not carrying any variable. So the y dx here, there's no x here to be equal to 0. Now, before I continue, let me make you understand this. Normally, a function that we derive, find the derivative is always of the form we have ax raised to power n. Let me start with this. So if we have y is equal to ax raised to power n, you have to find the derivative of this function with respect to x here. Two things are to be noted here. N and a, they are constants. So what does that imply? It implies that the y, the x, will be equal to what? This power will come down. You have n, then times a. Do you see that? The power comes down, multiplying whatever it is, whatever the coefficient of x is. Let's now multiply that, then you have x raised to the power of n. Then this power, you subtract 1 from it. That's all. That's the derivative of that function. So which implies if we have, for example, I say y equal to 2, normally I can write this as 2x, assuming since there is no x. So I say dy dx. It means here x is 0. X to the power 0 is 1. So you have 2x to the power 0. And if 0 multiplied, that is 0 times 2, then minus 1. This is still 0. Since the product of 0 times any other thing, it will give you 0. So that's why we said that dy dx there is 0. 2. If a is a constant, then d dx, of course, if you have a function, a constant multiplying a function, and you're looking for the derivative of that function, you can just pull the constant aside. If it's a product or division, you can factor them out. Let me give an example on that. You have this. Please pay attention. Okay, let me use this, please. You have, for example, you have y is equal to 2ax. So the y dx definitely will be what? A, open bracket, or yes, then find the what? Okay, let me write this as y can still be written as a, open bracket, 2x. You get it? So we can just say that the y, the x, you have a, open a bracket, what? So you have this 2x, you are looking for a derivation, now you say, now you cannot find the derivative of this. That will be 2 times 1 The power of x here is 1 times 1, then x raised to the power 1 minus 1. So that becomes a times what? So you have 2 x, that is x raised to the power 0, that is 1. So our answer is 2a. Divide the x is 2a. Do you get that? So we have that. Let me clean this so that I don't distract what I was doing. That is the explanation for that. If u, v, w are functions of x, if they are all functions of x, the sum of d dx of all those functions of x will be what? D du. You split this over, that is, you differentiate them individually. Du dx plus the v dx plus the w dx, and on. If you have more, you go. Simple. The product rule: if u and v are some functions of x, then d dx of uv, of course, that will be v du dx plus u dv dx. And this, you find the first function. Okay, I will explain this in another video because this is another video on its own. A video on its own. Then quotient rule: if u and v are some functions of x, then d dx, that is upon or open against u over v, that is what? Quotient rule. Quotient means division. This upon this. So we have this to go, we treat it as examples. Now I need to explain this, or I write this out as, okay, let me make an example first. Example 1. Okay, we have 3t cubed plus 2t squared, 3t cubed plus 2t squared minus 7t plus 3. So this is y is equal to this. So we have the y, the t. We are differentiating this with respect to all this, with respect to t. So you look at each of them, this 3, until the power comes down. So you have 3 plus 3, then t, subtract 1 from the power, minus 1 plus what? 2 product 2, that is, this multiply this, then t raised to the power 2 minus 1 minus 7 product 1. The power of t is 1. So you have that, then t raised to the power 1 minus 1, then plus what? There is no constant, there is no variable rather here. And we have said the derivative of a constant is 0. So you can just write a 0 right away. So here we have what? 9t squared plus 4t minus, this is 1 minus 1 is 0. T raised to the power 0 is still 1. So that is 7. So this becomes our derivative. If you are told, for example, find the square y, the t squared, that's the second derivative. So we can equally repeat the same thing after you've gotten this answer. So the square y, the t squared is the derivative of the y, the t. So you have this, you have, which is the same thing as 2 times, you have 9 times 2, t raised to the power 2 minus 1 plus 4 times 1, t raised to the power 1 minus 1 minus this. Derivative of which is 0. So you have 18t plus 4. You can see further find the derivative of further derivation. But that is not why we are here. We'll move on. That is just an example. So we go now. Let's look at the derivation of special, or look at special derivatives. I need to explain this before we start talking about the rules of the differentiation and methods by which you can differentiate. We have a lot of them. We mentioned them. The first principle that has been done in the first video. Now we're talking about product rule, quotient rule. We need to talk about those ones. So let's mention this first. So we have a function. We have f of x. Here we have f prime of x. F prime of x means the derivative of x. So this this, you have 1. I need to be drawing this out. If you have x, definitely the derivative will be 1. Yes. This 1 times this, 1 minus 1 0 is still 1. So if you have 2, so we have cos x. Cos x, the derivative of cos x is minus sine x. Please note that. Note that. 3. The derivative of sine x itself. Find the derivative of sine x, you will get cos x. 4. The derivative of tan x. Yeah, I can show you this. Of tan x will be sec square x. We show this when we are dealing with quotient rule. Yeah, we'll show this. So 4, we have 5. 1 over tan x is cos x, right? So differentiate cos x, we are going to be having minus cosec square x. 6. If you differentiate, okay, let's find 1 over cos x. 1 over cos x will give us what? It will give us sec x. You see that? And tan x is giving us sec square x. So sec x will give us, the f prime will be sec x tan x. 7. We have cosec x. So cosec x will be what? Don't forget, cos x, if you differentiate cos x, you have minus cosec square x, right? So cosec x will be carrying minus, but will now be cosec x what? Cos x. Good. Then if you have this, let me stop here. You have exponential of x. You have exponential of x. What do you have? That means you are differentiating this, the core. This is a core, this is a function, but this is a core. You differentiate this, bring it here. You differentiate x, you get 1. So the answer is still exponential x. But if you have, for example, you have exponential 2x. You differentiate 2x, you have 2, then times exponential of 2x. This is what we're going to be having as our answer. Do you get it? So that is what you keep having. Then 9. Let me include 9. Let me see if I have other functions I can include. Yes, we need more special angles, special functions. Okay, I don't think I have one here. So let me just put the one I remember. You have log x. So what do we have? This one, if I find the derivative, you have 1 upon, differentiate this. So you have 1 upon, there are different ways you can go about it. So because of that, I will include, I won't want to, I have more examples to give on this. So let's leave it as number 8. I will make mention of this in my, when we are having examples on differentiation by products, quotient, chain, implicit, and the rest of them. Thank you for joining. Please do not forget to subscribe. Don't forget to subscribe. When you subscribe, it's not sufficient. Please, you like, you make your comments. Please, make your comments. And as you wish, you can share. Thank you very much for joining. Okay, I thought of doing something here. Yeah, I thought of doing something. So instead of, let me leave it out, let me quickly add it so that you won't feel I want to deprive you of that knowledge. but I was thinking of something the other time. So if you have log x with e, that is a natural log, or you have it as ln x. What do you how do you differentiate this? You pick, I mentioned this as a call, right? So these two you pick, this is the call. If you differentiate x, you have 1. So your answer is 1. Then over the function, that same call, 1 over x. So such that if you have log we have log 2x squared minus 3x. So dy dx will be what? Differentiate this. If you differentiate this, you have 4x minus 3, then everything over this same call. That will be 2x squared minus 3x. You get that? So that's how we go about that. If you like, you solve more and get more understanding.